Welcome back to the continuation of our videos on Java primitives or primitive data types. Now that we've seen numeric data types in Java or numeric primitive variables in Java, let's look at other types. So we said in the beginning that there are 8 types of primitives in Java. We saw that 4 belong to numeric variables: byte, short, int, and long. We saw that 2 more belong to numeric but floating point numeric variables, right? Floating numeric variables. Now we're left of 2 more. What these 2 more might be. Now let's do this. Non-numeric primitives in Java. There's a special type of primitive called char. Okay, this is a short for character. I'm not gonna type it in here. So as not to confuse you down the road. This is called textual data type. Okay, let me put it here, textual data type. And the abbreviation for it is char. Oh, I'm sorry, the declaration for it is char. Let's look at its size. Its size is 2 bytes, 8 bits. Let's do this. Let me not following the idea to confuse you, but I'll explain why I'm gonna do this. But let's put here that, oh, this is 16 bits, right? I'm sure some of you have already tried to correct me. The size of a byte, I'm sorry, the size of a char is 2 bytes. It is, every time you declare a char, it has 16 bits or 2 bytes of memory allocation. 16 bits, as we remember, means total possible value of 65,536. This I copied over from short, right? Now you're gonna, and char being a textual data type, for example, let's do this. Examples of char, right? Is going to be A is a char. Capital A is a separate char. It's not equal to A, right? For computer, for a Java program, this A and this A, they are completely different chars or characters. M is a char. Dot is a char. Comma is a char. Semicolon is a char. Space itself is a char, right? Underscore is a char. Tab is a char. New line is a char, right? You remember how when we looked at escape sequences, we talked about tab being written by a backslash, new line. These are all chars, right? There's a funny declaration of a default value for char, which is \u1234, right? 4 zeros. I'm not gonna dive into this, but this default value, let's put it here, default value is this, right? Brings us to the concept, back to the question of why do we have 2 bytes allocated for a char? Why do we have 65,000 potential values of the char? To do this, let's put here a note. This is called ASCII table. I don't know what ASCII stands for. I never tried to remember it. But ASCII table is basically the standards of defining chars and their values. Let's do this. Let's go to Google, search for ASCII table. Let's go to images. Let's find one quality ASCII table here, which I can zoom into on. Now, this is too confusing. This is going to be, yes, this is something that we need. Or not, no, this is hexagonal values. Let me see if I can find one. What about this? Decimal value, yes. Let me see if this website is going to let me zoom in with a quality. Okay, let's zoom in on this first. All right. Now, when we said a char has 65,000 potential values, this is what we meant. From Java's perspective, letter A, let's find letter A here. Letter A, right here. Letter A is not stored as letter A. It is stored as a 90 decimal value of 97. Okay? Capital A is a decimal value of 65. Okay? If this is most of these are all the keyboard symbols, right? These are certain values that I'm not familiar with, like control plus copy, control plus C, right? End of text from computer perspective, not a copy, right? End of text has a decimal value of 4. The reason why we say char's null value is \u0000 is because it kind of resembles a null value. Okay, so why do we have 65,000 possible values? Because, let me scroll down, this, for example, extended ASCII table takes us up to 255 values. You see all these characters? Some of you might remember this is a ch sound, right? This is a with what is it, apostrophe on top, a with an apostrophe on top, capital A. These are certain letters from different alphabets. So when Java was developed, the developers took into consideration that certain programming languages out there fail to address this, right? Because there are, what, 170 nations and at least that many languages out there with different characters. How can you represent all of them? You can represent all of them to the best by having a primitive in your programming concept, in the foundation of your programming, that is gonna have allocation of 2 bytes of memory with 65,000 potential values. Okay, now this is why we have char. This is why we have memory allocation for a char. Okay, I'm gonna stop this video here because next we're going to go into a logical data type, and that's gonna be slightly, completely different, but special concept. Thank you for watching.